Hello, everyone. Thank you for tuning into our virtual live event today. We really appreciate you being here. I'm really happy to be here. My name is Amy. I'm one of the customer success managers at the Web Spiders Group. And I hope you're all well. I hope you're having a good week so far. And today's webinar, we're going to be talking about cloud cost reduction strategies. So with more and more companies moving from servers to the cloud, reducing cloud infrastructure cost is critical. And it's a really, really exciting, current, popular topic today. And we've got a great panel of speakers to talk about how you can do that and how you can reduce the cost without sacrificing operational efficiency. So joining me today, like I said, we've got a great panel. We've got Suman, who is our VP. How are you today, Suman?
Yes, good. Thank you, Amy. How are you?
I'm well, thank you. Yeah, really happy to be here and glad to have you here to talk about all of your experiences. So thank you. And we also have Niladri. So you are our CTO. How are you today?
Yeah, hi, Amy. Yeah, I'm doing fine. So thanks for calling me in this webinar.
Thank you for being here. And Suvankar is one of our cloud engineers. How are you today?
I'm fine.
I'm glad to hear it. I'm glad that everybody is well, having a good week. That's a good start. So let's get stuck in. Let's go straight away. Suman, I'm going to aim this first question at you. I'm sure lots of people, on this call know about the cloud, but if we're going to be talking about the benefits, if you want to start us off just by telling us how economical this really is and beneficial from a cost point of view, and why is this so dominant? If you can start us off by just explaining a little bit about why you think this is so dominant in your experiences, and if it's really economical as well, to kick things off, please.
Right. Actually, that's a very interesting question, Amy. And maybe, the keyword I would say is the dominant. And this is where I will bring my first slide. Yes, over the last 5 years, 7 years, we find that, there's a big shift of adoption of cloud over on-premise infrastructure.
Yeah.
And there are obviously quite a good number of reasons behind it. We all know that, initial cost of, setting up a local network and the hardware system infrastructure, it takes quite a good amount of initial investment on that. But maybe after a couple of years, it becomes a bit lower, but the initial investment is quite big. Compared to that, cloud definitely has a much lesser initial investment, which is quite lucrative, for any business to start using cloud. But quite interesting is, Amy, over the last few years, what we see is that more and more people are actually adopting cloud. And if we see the present trend, the current, what we see is like almost 50% or more than 50% businesses, they are actually utilizing cloud infrastructures, which is comparatively, if you just see from this graph, it's like 38%, which is like purely, on-premise. And what is quite interesting is next 1.5 years, these numbers are going to be even more polarized. And then we'll find that like only 25% will be on-premise. And the remaining almost 70% will be utilizing, like cloud and so some way or the other, either completely cloud or maybe a mix of cloud and on-premise. Now, so that's the reasons, as I said, there are a few quite good number of reasons, and one being obviously the initial investment, and also on the other hand, what happens, is there are quite a good number of services. It's not just the physical infrastructure. It's also the services which are on top of that. For example, the firewalls, for example, streaming services, and there are many different kinds of services which can be on top of that. If we need to implement all these things together, it's an even bigger investment. But here we already have an environment which is there, which is ready, and we just need to hop on that. And it's all shared. So overall, definitely the cloud infrastructure, the costs are definitely much less. Now here, Amy, what I would really like to emphasize is, I mean, if we look at this chart, I mean, this is what we are expecting, that initially there will be a big, rise for the cost, initial investment, and after that, the graph actually flattens out for, on-premise infrastructure. But on the other hand, cloud initial investment is less, but gradually it grows up because more and more people are onboarding, the number of users grow, the hardware system needs to grow up. And finally, again, we are expecting that the cloud will also, like flatten the curve.
Yeah.
But here again, something quite interesting happens, and this is the reality is actually quite different than what we see here, and what we see.
I was going to ask why the cloud price goes up so high, and other ways to reduce this, basically, because you can see how it goes up.
Right. In fact, we are expecting that the cloud prices won't be so high, but if you see this curve, I mean this graph, it shows that both the on-premise and the cloud, they both are on the rise after a couple of years.
Yeah.
Which was not what we expected or what we expect. And there are quite a good number of reasons again behind this. For example, for on-premise, there is a cost of maintenance. And on-premise means we need to have, like manpower to constantly maintain that on-premise servers. And also over a period of time, we constantly need to upgrade the servers. So the maintenance cost is quite high. And after a few more years, we may even find ourselves in a position where the current hardware system is not enough to cope up with the new systems. And then we need to completely upgrade or maybe overhaul or replace the existing hardware systems. So this graph is quite understandable for on-premise, but for cloud, it's a completely different story.
Yeah.
The initial rise is quite understandable, yes, but after, let's say, 2 years, 3 years, we see that the curve still grows up, and that is not something we were expecting.
Yeah.
And the reason behind it is, again, poor management of the cloud infrastructures. And this happens because the basic nature of the cloud, it creates a playground, where it literally creates an environment where you can very easily go wrong, and then it suddenly becomes the investment, the maintenance costs grow up and up and up, and finally it goes to a level where it actually becomes less beneficial than on-premise. Yeah. And what we see is that recent studies show that almost 80% of businesses they report negative impact from poor cloud cost management. And there can be many reasons for that. Again, waste and sprawl of unused resources, suboptimal service levels, cloud migration costs can easily balloon, over budget and grind the process to a halt. So there are many reasons why this cost can really go up.
Okay.
And so to come to your question, why it goes up, yes, and how to control that.
Reduce it. Yeah. That's really great. That's insightful. Thank you.
So in order to control that, Amy, as I said, if it's not properly managed, optimized, monitored, it's going to create that problem.
I see.
So the whole idea is to monitor it very closely.
Yeah.
And as I said, the inherent nature of the cloud is it's based on a variable cost model. Yeah. And in order to bring some predictability into it, to add some accountability to it, to make it more optimized, that's basically the way to bring down the costs.
I see. Yeah.
Right. So this slide, if you see, one very interesting thing is the speed, cost, and quality triangle. And this is a very interesting thing. Obviously, if we increase the cost, we can have better resources, we can have better, more speed of our infrastructure, a better quality infrastructure. So it's very easy to increase the cost if we try to increase the speed or try to increase the quality. So we need to strike a balance between all these three parameters, finally, so that the overall cost can be brought down. So the key lies in monitoring it very carefully, planning it very carefully, and then optimize the costs over a period of time.
Yeah, and I guess essentially that attention to detail, if it's managed properly, if you don't have the time or if you become lazy with it, then you can end up paying more for it. But if it's managed properly, yeah.
Exactly. And that's the reason, if you see this graph again, this is what we are targeting for, the on-premise cost, obviously, after a certain level, it cannot be reduced any further. Because you will still need to upgrade your system, you still need the manpower, and over the years, the inflation rates and everything, the curve is definitely going to go up. But for cloud, what we are trying to do is cumulative, subscription cost over a period of time. If we can keep it lower than, the cost of ownership of on-premise systems, and again, the cumulative maintenance, the maintenance costs, if we can equate that over a period of time, and if we can, somehow keep the cloud costs below the on-premise costs, then after a certain period of time, let's say 8 years, 10 years, again, there will be a spike in the on-premise costs, because again, you need to procure new hardware and new systems. So if we can keep somehow this cost for cloud subscriptions to somewhat lower than the on-premise cost, then that is actually much more beneficial.
I see. Perfect. Thank you so much for the graphs. It's very easy to see. It makes it more simple when you explain it like that. That's really, really insightful. Thank you, Suman.
Thank you.
So now we're going to move on to our first point, and this is really for you, Niladri. And in terms of the beginning, the very start, the startup, is there anything that we can do to reduce the cost from the setup? So right from we're talking about the provisional cost here. In your experience and with your knowledge, is there anything right from the get-go that you can suggest would help reduce it from setup?
Yes. So there are few factors which we need to keep in mind while provisioning the resources for the first time in the cloud, because where we don't have much idea about the expected load or something. So the first point is select the correct cloud instance type. So that means most of the clouds, they offer very purpose-built instances for specific workloads. They are called compute memory or computers memory or storage optimized. Compute is a fancy word for CPU. So for example, you have a very heavy data processing job or video image processing job. So that is what actually CPU intensive job or compute intensive. Then you really need to provision a compute intensive instance, because if you go for the other options like memory optimized option, then the kind of machine that will match your CPU requirement, the memory will be enormous and expensive, which you don't need to pay because you don't need that, right? So that is very crucial. You choose the right type of instance based on your workload. I mean, the nature of your workload. That is the first key point when you start creating or provisioning resources for your cloud. And at the same time, when you create an instance, you need to select some AMI. AMI are, you can say, kind of software stack. So that is also you need to take care of, because free and open source softwares are much cheaper instances with open source AMIs. If you don't need licensed softwares, like for example, you are running a say mean stack application or application, so you don't need really Windows systems, or you can easily use Linux AMIs, which are way more cheaper. It's around almost 50% cheaper, I believe, for servers. And Similarly, for databases, if you don't need proprietary databases like SQL or Oracle, which are really expensive, you can easily go with Postgre or MySQL, this kind of things. So those are the things. And the another thing is the chipsets. That's important because most of the Intel-based chipsets are really cheap, costlier. So if you see your work, I mean, most of our works, like especially the backend applications, etc., they run quite well on ARM or AMD chips. AMD chips. So if you find that that will suffice your purpose, you should go for them, not for Intel chips, because you will be unnecessarily paying extra amount of money which you don't need. Yeah. So then let's come to the next point. That is, make use of reserved instances and spot instances. Actually, they are saving plans in a different blend, different flavor offered by different cloud providers. They're nothing but charging different rates based on your commitment, upfront commitment. Okay. So in this scenario, you commit to consume some definite amount of resources for over a long period of time, and in turn get discounts. So it depends on the amount of discount, depends on how much you commit in terms of volume and the period, of course.
Okay.
And also how you are paying, how much you are paying upfront and how much you are paying monthly. So you can think of reserved instances like for a running production system with continuous load, which is known to you because you have observed that for say last 6 months. Okay, these are my loads. I know this is the highest peaks we have achieved. So I'm sure if we can reserve say 3 servers with that load, it will suffice our purpose and we'll save a lot of money by doing that. So next, so this one actually lays out 3 types. One is the general, normal, the on demand. So when you create an instance, by default it is on demand. That is the costliest one.
Okay.
So you pay for capacity you choose. This is suitable for spiky workloads. The workloads you cannot anticipate, which varies widely, and also you are not sure about the time period during which it will be required.
Yeah.
And next is the reserved instance. That is, you make a commitment to definite volume of resource for a definite period of time, and you get discount instead. For example, if I commit say 10 T4 medium servers for 3 years, so the total yearly cost will be way lower than if we go for the on-demand option.
Yeah.
The only caveat is you have to pay upfront. Now they have option for not paying upfront, but you save the most when you pay upfront. Even if you don't pay upfront, it is still cheaper than the on-demand.
Okay.
Just you have to do the commitment, that is, you will be charged monthly during 3 years.
Yeah.
And there is another interesting type, that is a spot instance. Spot instance are how they use their unused capacity, because they have a lot of servers. All of them are not used. What you can do is you can bid for unused capacity, and you can set the amount that if that amount is any server of this much configuration is available within that amount, I want to book that and send me an alert when it is available. So this is really cheap. You can save even up to 70%, or even at times it's even more.
Okay.
So where do we use it? Where actually it needs some kind of one-time work, which is not very time critical. Okay. For example, if you want to pull data for data migration, if you want to pull data from a legacy on-premise system to a cloud data store, so that can happen anytime between say next 3 days. So in that case, it is always the best way to book for a spot instance, and you calculate, well, that job will take hardly 2 hours, so book it for 3 hours.
Yeah.
So when you are done, it will automatically be decommissioned, and you'll be paying only for those 3 hours with such a cheap rate. And some facts and figures in the next slide, and you can clearly see how much you are saving. So we have taken a typical case of M4 large instance type and different pricing models, different levels of commitments we are making and how much we are saving against each type. So first, the on-demand, the standard one, where you don't commit anything, that comes to your yearly cost. I believe it's North Virginia, right? Okay, yeah, so 878 yearly cost. And then reserved instance with no upfront is 543. So even if you don't pay upfront, still it is way cheaper, you see. And then also the more you pay upfront, you finally you achieve all upfront 507. So it's much cheaper actually. So if you can pay upfront, then that's the best option. You save in long run. So this is how these reserved instances should be used. Actually, they are not used very efficiently, but if you can use them, you can really benefit from cost point of view.
Yeah.
Okay. So another is select the lowest cost region. That means these cloud providers they are spread over different regions across the world, and the usage rate varies from this region to region. So similarly, the rates they charge in these regions for the same type of resource varies widely. You can see the level of variation. So in the same resource is charged in North Virginia like 374. The same resource in Sao Paulo is 571. So if the region is not important to you, not of that much importance for your system or workload, then you should definitely go for a cheapest region.
Yeah.
Because once you sign up, you can choose any region you want to.
That's great to know. Yeah.
That's a really that is another point really people overlook. So they generally pick up a favorite region.
Yeah.
It's nice, and then start creating resources from that. But some resources are really vary. I mean, like EC2 or maybe the Redshift or those things really vary from region to region. That's quite significant.
Yeah.
Yeah. The last bit in this section is craft the right application architecture. So you may want to know how it is related to cost optimization, right? So, for example, because at the end of the day, that it is the application which is consuming your resources, right? So definitely how you design that applications, how they consume the way they consume the resources will definitely impact your cost. For example, if your application stores documents, images, video files, kind of these things, you can consider storing them in blob storage instead of the block storages, which is way cheaper than block storages. Ideally, the blob storages should contain only the application executable script files, configuration files, which are required to run the application itself. So that is one really big consideration, because this cost is significantly different, because blob storage is quite cheaper than the block storages. And another point you can consider, that is the very frequently called serverless functions. Serverless functions are called in Lambda in AWS or cloud functions in Google Cloud. So they actually you have to pay per call. You need to be very careful because before you use them. Suppose you need a queue processing routine which needs to be called more than once a second. Okay, so if you do that in Lambda, you can imagine how many calls you'll be charged for in a single day or month, and eventually in a year. That can easily overrun the cost of a medium EC2 instance. So in those cases, you should look for alternatives like a hosted service on a moderate EC2 instance and serve from that, so that you don't charge per usage. Another is there is a hidden factor, that is network data transfer, which is hidden because you cannot find it anywhere in your admin console. Okay, so it only appears on your monthly billing on the item. So that is the amount they charge for the amount of data that your application transfers through their network, within their network, right? So it includes both outgoing and incoming traffic as well. So you can craft your architecture to control that as well. For example, you can optimize the APIs to supply the data only the amount what is required, or even for the applications which calls from client, the client side can use caching if you don't need a very real-time data, so you can avoid unnecessary round trips. That's one way. And yes, that is mostly the prime factors you can think of while before provisioning, or while you're provisioning the resources for the first time.
Yeah. I think there's lots of important and interesting points that you've mentioned there. Definitely taking note of those. So thank you. Very insightful. And so that leads us naturally on to talk to you, Suvankar, more about. So we've kind of covered the initial cost, the setup, the provisional cost there, and in terms of reducing the cost, but going forward, so into the maintenance cost.
Right.
In your opinion, how is best to keep the maintenance cost going down going forward once you've initially set up?
Yes, I'm telling you. Actually, as Niladri told, okay, the provision, when we are provisioning any kind of resource into the cloud, it is very important to choose the right resources. Okay, what kind of resources we need to, it should be pre-planned, right? But in some cases, we have seen that okay, at first they are pre-planned, but somehow after finish their work, they are not monitoring it properly. Means they are not identifying whether the work has done or not, or if work has done, but still they have not stopped the instances. Okay, they have not stopped the resources, but still it is charging. Okay, so in that case, what we need to do, we need to focus okay, whether the resources are finished their work or not. Okay, if it is finished, then we need to stop the instances or remove the resources. Like I'm giving you an example. Sometimes we have seen that okay, we have hosted a server into the cloud and it finished its job, but still it is running. Okay, or someone has terminated it, but it has not deleted its EBS volumes, because normally when we stop or terminate any kind of instances, still its EBS volumes are attached and it is charged. It is charged. Okay, so in that kind of cases, we need to focus first thing. Second, like I'm taking another one example, like elastic IPs. IPs is very important because every servers or every resources are identified by this IP only, right? So when we are accumulating or when we are using any kind of IP and after stop its instances, we are not releasing it. That means it is going to charge. I'm giving you an example like for the North Virginia region, it is going to be charged around $3.6 per month. Okay, so we need to be very careful. So what are the stop resources? What are the stops and remove resources? So for that, any connected resources are still working or not, we need to check that thing. Okay, then EBS, if I'm going to take about the examples of the EBS volumes, load balancers, EC2 instances, means we need to check. Second thing is we need to monitor it properly. Whatever the resources are working in the cloud, we need to set a alarming system, means monitoring system. Okay, if it is utilizing high, then you should to notify, means you should to get the notification, right? And sometimes it is not utilizing that much of resources. Like I'm taking an example. At the time of provision, I have taken CPU around M4 large, but in last 5 months we are checking okay, it is not utilizing only 30 to 40%, not more than that. Then what we need to do, we need to just downgrade that server's specifications so that it can be properly suitable, means we can optimize that thing. Okay, so in that way we can reduce the billing. And another one, just go for the next slide. Next slide. Here I have already told. Yeah, the object-oriented storage. Object-oriented storage means, as Niladri have told, EBS means block storage. Block storage are a little bit expensive, because when we are creating any kind of server, we are generally stored the application files, OS files, all these things, and side by side we stored some supporting files as well, like video files, like any kind of TXT files or HTML files or any archive files. Okay, so these things should not be stored into the block storage. It should be stored into the object-oriented storage. Means S3. Okay, because S3 is cheaper than the EBS volumes. Okay, and in S3 also there is a 6 types of categories actually, according to the usage and its costing. Just go to the next slide, Suvankar. Okay, here you can see we have already mentioned the 4 kind of storage. One is the S3 standard, another one is the S3 standard IA, and another next one is the S3 one zone infrequent access, means there is also a IA, and the Glacier. So before telling you the costing part, I'm going to tell you what are the main function of all these classes. Generally, standard are very ideal for the performance and frequent access. Means whenever we are trying to double click on that, and it should be open like a lightning of speed, right? So this kind of thing, for this kind of thing, we can use the standard one. Okay, generally standard one is the by default. When we are going to store some data or into the, means when we are uploading the data to the cloud, by default it will be the standard one. Okay, but it is the costliest one, whatever the classes it has. It is the costliest one. So when we are uploading the data, it should to be checked. You should check which class you are going to upload the data. Whether you should the data should to be frequently accessed, or it should to be accessed only for the 30 days or 15 days, or it should to be accessed more of the around 1 or 2 years. So according to that only you should to choose your classes. And the plus point of the standard one is, when we are going to upload the data, it is going to be stored into the 3 different regions. Means if any region is 3 different AZs. If any AZ are going to be impacted, then automatically that other 2 AZs is going to give you the availability. Means it's going to give you the support, so that you can still access the data. Okay, this next one is the standard IA, that's called the infrequent access. It is an intelligent tier, we can say. It automatically accumulates. It's going to be checked whether your data, when you are accessing, means if it is checking your data is not accessing in last 30 days, then automatically it transports the data to the infrequent access mode or classes. Okay, because infrequent access is cheaper than the standard one. Okay, so I believe always we need to use the classes when we are going to upload the data into the cloud. And the next point is the S3 one zone infrequent access. So what is the difference between see, one zone infrequent access and standard infrequent access? Both are almost same, but there is only difference. Okay, in the standard IA, it is going to be store your data in the 3 different AZs, whereas the one zone infrequent access is going to store your data only one zone, one AZ. So if your AZ is going to be impacted, then you can lost your data. So keep it in mind. According to that only, you need to store your data. And the Glacier means it is the cheapest one actually. Means we can say what are the data are not going to be accessed more than a year, or maybe possible to once or twice in a year. So this kind of storage data we are going to store into the Glacier. That's the cheapest one. So in that way we can reduce our cost. So this.
So I have a question for you here. Just go to the previous one. Yes. So we can see the S3 standard is the costliest one. The Glacier is the cheapest one. Right?
Cheapest one, right.
So by default, when we are creating objects, it goes to the standard ones, right?
Right.
Now, say for example, I have some data files. I save them in S3 standard, and once they are processed, I don't need them that much, only for some compliance or regulatory these things. So they can be easily moved. Once they are processed, they can be easily moved to the standard IA, and maybe after 6 months, they can move to Glacier. Even so, we need to retain them in the cheapest possible. So is there any automated process I can do? I can define some lifecycle policy or something like that.
See, in that case, you do not need to require any kind of recycle policy, because automatically, see, in the Glacier also we can get access. If it is data is stored in the Glacier, we can access it. But yes, it may take some time to access it, because from the long run, it is not going to be accessed, right? So that is why it came to the Glacier, because you are not accessing almost 1.5 years. So that is why it came to the Glacier. We can Glacier, we can access the data in the for the Glacier classes, but it may take some time, and it is charge you little bit for that.
Okay, great.
Okay. And that already Niladri had told already about the caching. So if you required the caching, then you should to go for. But if your data means, if you don't need to put the burden on your servers, then you should check all these things like CloudFront and your ALBs, all these things with the CloudWatch. So CloudWatch is very important, because through CloudWatch we can get notified whatever the ideal resources are ideal in that condition. Whatever not the ideal, I think we should to stop the service for that. And here is the graph of the notification. Here we can see we can do it through the Watchdog or CloudWatch as well. Okay, when the bills are going to be here, what we need to do, we need to set a point. Okay, after 70% or after 80%, when the bill is going to be reached, at that time we should notify, and for which purpose means, or for which services it is going to be charged. That also should be notified. We can do it with the cost tagging. So we need to implement here cost tagging, and we need to create a proper budget. Okay, and the proper monitoring system. So the diagram tells the same.
Yeah, it's pretty good actually. I can see that I can have the alerts in my own system as well, not only there.
And actually, that brings to another question, Niladri. I mean, more for you, this question. So, I mean, definitely what we see is that if we do a proper monitoring, a proper planning, and there are obviously alerts which can constantly update us if something goes beyond a certain threshold. Definitely by all these processes, the cost can be reduced to a great extent. But Niladri, is there anything else which can be done, like some certain processes which can be implemented, which can actually, over the long run, can bring the cost down further?
Yes, we can follow some practices, some best practices, like try to institutionalize some principles. Like, for example, efficient tagging of resources. Tagging means you can attach some kind of text with the resources. It could be based on your application system, or the resource type, or the business unit, or the account. So the purpose is, they provide actually very clear visibility and traceability on how much resource, how much you are spending on under which head. So, for example, if you tag the instances based on application, so you can, in the billing, you can see the breakup that application X has consumed this amount, Y has consumed this amount. So based on that, you can put further control or make business decisions. So that is one thing really important. And for very large enterprises, for example, with presence across the world, there are other groupings as well. You can group on resource groups, business units, organization units, all those things. So the main purpose is just to find out where we are spending how much on which head actually. So that is good control. And the next one is Suvankar already touched this point, the considered auto-scaling model, because if you are not sure or you have a system with a very varying load, you can go for auto-scaling. Auto-scaling is dynamically upsize or downsize based on your load, and you pay for what you use. Apart from instances, it also applies to database systems. Okay, so it can be on this non-SQL databases as well. So you can choose that, the auto-scaling model. And the next part is also related to that. Yeah. So consider scheduled stopping or resizing. So if you don't need resources, you can either downsize or you can even stop. For example, we worked in a system which actually had a very peak on the first day of every month. Okay, so in that case, the scale was in normal days you needed only 2 web servers, and on the first day for 2 or 3 hours you needed 10 web servers. So imagine you are maintaining 10 servers throughout the year only for one day in a few hours in a month. So there you can very efficiently use scheduled stopping or scheduled resizing. Okay, so maybe on the 31st or the last day of each month you can scale up to 10 servers, and on the second you can scale down to again to 2 servers. So you are actually paying for one day per month. So this is one thing that is really not possible or extremely difficult to implement on premise. So you cannot go to the vendor and procure servers as you require and return it when you are done with it. So that's simply not possible. Okay, and also you can even stop them. For example, you live telecast sports events or matches. Then you can definitely shut the systems down when there is no event or matches. So that's also one use case for schedule stopping. And you can automate that. You can automate the schedule so that you don't forget or it works properly. The next is you can implement resource creation permissions and quota policies. This is just to put some control on to restrict abundant and uncontrolled creation of resources, and especially not being deleted or decommissioned after they're being used. Because a lot of people uses immediate instance. This is very easy to create an instance, right? Provision one instance. So you can you want to do some R&D work, you can provision a very high configuration machine, and when you are done, you forgot to decommission it. So you can put quota on that, like on individuals, groups, and business units. So whenever these things get piling up, it will restrict you to create further resources until and unless you clean up. So that is also one thing that you can follow organization wise. And the last point is a bit of interesting: automate infrastructure deployment as much as possible. Now you can wonder what it has to do with cost control. It is more of deployment management or CI/CD, whatever, how it can affect cost. But the thing is, the cloud vendors, they allow you to create pre-configured cost optimized resource templates for different use cases. Okay, so for example, you need a PHP system with moderate usage, like 2 web servers, 1 database server, or something like that. So you can create the whole thing and save as a template, and that you have done the necessary cost optimization. So you can force the people who are in charge of creating the resources to use that template and create them in an automated way, just to accidentally provisioning the overpriced resources, which is not cost optimized. So that is one thing you need to take care of.
Amazing, Niladri. Yeah. So what I understand is basically, so it's the right strategy, first of all, proper planning, and then provisioning the system very step by step, and making sure we constantly monitor it and have proper controls in place, and obviously quotas, and selecting the right infrastructure, right items. So these are the different ways through which we can actually bring down the overall cost. And Amy, from the point we started, that if you see that green area, that's exactly that area defines the cumulative cost reduction, over the years, and which can really bring down the overall cost, the expenses to a great extent.
Yeah, that's a big difference. You've shared some really, really helpful tips on strategies today. Thank you all so much. It's been very insightful. I'm sure our attendees will agree that it's been a really great summary of best practices that we can take away and move forward. And the difference here that you can see on the graph is it's a no-brainer. You know, listening to everything that you've shared today will help so many people. So thank you all.
Yeah, thank you, Amy.
Thank you. Thank you.
Great. And so now we're nearly at the end of the session now. So I'd just like to invite you all over to join us on a roundtable session. We can jump straight across after this this session ends. We'd love to take your questions. I'm sure you have a lot of questions to ask still. It's been such an interesting topic. Thank you so much for listening. Thank you for attending this session. And if you're not able to make the roundtable, please do go to our website or reach out to us. We'd love to answer your questions or help you further. So enjoy the rest of your day. And if you are joining us, let's jump over to the roundtables now and discuss, open up the roundtable there, okay? Thank you, everyone.